Hello and welcome to another video. In this video we're going to be working on zero array transformation 2. That was an interesting one, so I wanted to make a video on it. Definitely a harder of the mediums for sure, so let's get into it. So in this one you're given an array and queries, and each query represents the following action. Decrement the value at each index in the range of left to right by at most val. The amount you can decrement can be chosen independently. A zero array is an array where every element is 0. Return the minimum possible non-negative value of k, such that after processing the first k queries in the sequence, nums becomes a zero array. If there's not a k, return -1. So basically what they mean is, in a query, you can essentially just decrement everything by 1. I think they tell you by 1, right? Or no, by value at most, but things won't get negative. So you can just greedily take the whole range and decrement it by as much as you can. So what that would look like is for the first query, this would go 1. This is already 0, so you can't do anything else. And then here. And then second query, we do it again, so then we can get 0 and 0. And so the answer is 2 here, and they tell you why. And in the second example, so 1 through 3 gets decremented by 2, so that's these. So this will go to 1, this will go to 0, this will go to 0. Then in the second query, these get decremented by 1, so this will stay a 3, and this will be 0. So this is never 0, so -1 there. And the queries is 10 to the 5th, and nums is 10 to the 5th. So the brute force is pretty simple. We can just, like, for every query, manually decrement numbers, and then maybe keep track of, like, how many numbers are 0, and then once every number is 0, we can return that. And that would be n by m. So we want something better. And this is where you can use a line sweep, and I've talked about line sweep before. So line sweep, basically all it is you have like a number line, and you just mark down at important points, do I increment something or do I decrement something? And then if you go through your number line and you hit some number, you can basically adjust your total. So let's see what that would look like. Let's just draw a number line. Okay. So let's say, for example 1, so at index 0, we're incrementing everything by 1. So we'll say at index 0, we're incrementing everything by 1. And you want it to be incremented all up until 2. So from 0 to 2, you want it to stay at 1. So what you can do there is you can say, well, at the index after my index, let's just decrement by 1. So here we'll get -1. And then what will happen is all of these will be 1, and now here it'll be 0. So that'll essentially do that for you in O of 1. Second query is 0 to 2 by 1 again. So same thing. So we're just going to add on to this. So this is 1 more. So now this is 2. And 1 is like this. So now if I walk through this and get a running total, what would happen is at 0, there's a 2. So my total is 2. At 1, there's nothing. So my total stays the same. There's nothing here, my total stays the same. And then right after this, my total drops to 0 because I do 2 plus -2. So we can basically mark down points on a number line that are relevant to increment and decrement, and then we can get stuff quickly. Let's walk through the second example for the same kind of thing, and then we'll see how we can use this. So we have query, so this is from 1 to 4, so same thing, 1 to 4, or 0 to 4, and then the one right after. So 1 to 3 is 2. So at 1, we'll mark 2. And then at 4, we'll mark -2. Which means the same thing. All of these numbers will be 2. Yeah, if we just do if we just maintain a cumulative sum. And then 0 to 2 is 1. So 0 is 1, ends at 2, which means we'll mark it at 3. So now let's walk through what our totals would be. So here, our total is 1. Sorry, our total is 0, because you don't... Actually, no, our total is not 0, it's 1. Here, our total is 3, because we're going to add. Here we have nothing, so 3 still. 2, 0. And if you actually perform these queries, that is what you would get, right? So you would get... is that right? Yeah. So if you were to do a prefix sum, basically, on these queries, you would get this thing, right? So 1, 3, 3, 2, 0. Because the first number only gets incremented in this query, second number gets incremented in both, third number gets incremented in both, and then fourth number is not incremented anywhere. So yeah. Okay. So essentially you can use this like if I have this array of at every index, like what's my total thing, then I can figure out, like, I can just maintain a current sum and then check my current sum. So we're trying to get everything to 0, but we can kind of think of it the other way, where we can say, for all these queries, let's add these to our number line somehow. And then if at a number, our total is n or more, it means we were able to get that number down to 0. So like if here's our total is 3 and n's like 2, that means we could do 3 deletions, so we'd have 0. So essentially, if our line number is greater than or equal to n, we got n down to 0. Now, how can we actually use this practically in the problem? So what we can do is we can walk down our numbers and we can process queries. And then a query can be, so if we're at a number, a query can be in one of 3 things. And let's talk about what this means. So a query can be to the left of current number, include current number, or to the right of current number. So if it's to the left, what we're going to say is we're going to walk down our numbers and we're only going to go to the next number after our current number has been reduced to 0. Like after we've done enough queries to get our current number down to 0. And if we can walk through all of these, whatever query we're on at the end there, that's the answer. So if we're to the left, that means like if we're over here and our query is like this, we don't really care about any of this because this is already 0. So this just means ignore. Okay, what about if we include our current number? So our query is gonna in some way include our current number, like this maybe. This is our query. So here what we can do is we can say, okay, well, why don't we just add the value to the current number and subtract at the end of the query. At end of query on the number line. So like if this query, for example, is like +2, we'll say for our current number, whatever it is, we'll add 2. And then once this ends over here, we'll do -2. And then when we get here, we can just keep adding like what's on our number line. And then what do we do if the query is to the right of the number? Then we just mark both of those on the number line. So mark start plus end of query on number line. So that would be the case where like we're on this number, this has whatever value. Maybe the query is like this. So we're going to say that means that on the number line, we'll say this is plus whatever the value is. And then the index right after will do minus whatever the value is. And that way we can essentially basically just say, like, while we're at some number that we maintain a cumulative sum at, until this sum is greater than what we need it to be, which means we reduce it to 0, we'll just keep doing queries. And if we run out of queries, then we can return -1. And if we run out of numbers, then we return however many queries we process, and that's going to be the answer. So hopefully that makes sense how this line sweep works. Definitely a complicated problem. But hopefully that makes sense how, like, because we're basically keeping track of where we are as we go down, we can't like keep updating a prefix sum that's O of n, but what we can do is we can update these relevant points that the number is going to increase and decrease on very quickly. Okay, so let's code kind of what I'm saying. Hopefully it'll make more sense in the code. Okay, so we have n equals like nums. So we're going to make this number line. Call this like line. And the indices it can hold is going to be, so we'll make it all 0 for now, is going to be n plus 1. Because if n is 0 to 3, we still need to, at 4, mark minus val and so on. And then we'll prevent out of bounds errors this way. Okay. And our current index, or our current value, and our k index in our queries will be 0. All right, so we're going to go through our nums. So iv and enumerate nums. And we're basically going to add, we're going to add whatever the number was on the number line to keep track of our cur. So cur plus equals line I. Yeah. And then we need to check, while we still have queries left and our current value is too small, is not big enough to be this number's n. Because if our current value is nums n, that means we were able to get it to 0, essentially. So while k is less than length queries. I guess we can even do this. So while this is true, we are going to take the query. So the query has a left, a right, and a value. And we are going to go through our 3 cases. So the first case is if the query is to the left of our current number. So we're only moving from our current number once it's been zeroed out. So if it's to the left, we don't really care because it's all zeroed out. So if right is less than k, the query is to the left, we don't really care. And we'll just do this. If left is less than k, so this is the query is completely to the right, then we don't need to change our current number. We just mark the number line and then we move on. So line left plus val, and then the index right after the last one, which is right after right. That's why I made this one extra. We're going to subtract. And yeah, actually what we can do is we can say elif, get rid of this. So actually we don't even need, like this, we don't even care. So we can say this is if. Yeah, we can go if here, and then elif here. And then the third one doesn't do anything. So the second one is if our query is within range. So this is basically going to be like if L is less than or equal to I, which is less than or equal to right. Like now our query is actually on the number we're at. So we're going to increase our current number and we're going to decrease where this thing ends. We don't really need to increase from the left because like if the range we have is this, we don't care about any of this because this is already zeroed out. So we can just increase our current number and decrease over here. Okay, so this will be this, and then we can go line one. Yeah, and then the other case is if the query is completed to the left, in which case we don't need to do anything there. And so then we just need to go to the next query. Okay, so if we were able to go through this and we're still on a number, we need to check, like if we're out of bounds and we still haven't gone through all our numbers, then we need to return -1. So we could say if our current number, our current total, is still less than any number and we don't have any queries left, which we'll get to this case, then we need to return -1. And if we were able to get through the whole thing, return whatever. So the number of queries we process is just going to be the current index. So if we're on index 3, we process 3 and so on. All right, let's give that a go. Okay. But yeah, definitely, I'd say this is definitely a hard. Ooh, got an error. Okay. All right. I guess let's see where the error is. So we have our line, we have our k. Okay, so cur 0. Okay, so we're going to add our current value. While k is less than length queries, this is fine. Okay, this is fine. So if the left is greater than k, then we're out of bounds essentially. So all we have to do is just add the two things. That's fine. Otherwise, if our if our I is in between left and R, then we just add the value and we subtract afterwards. And we always increment k no matter what. Do we always increment k no matter what? Let's think about that, I guess. Yes, I think we do. Okay, so actually the problem is here, I think. So we did L is greater than k. L's never going to be greater than k. I think this is L is greater than I, so I just screwed that up. All right, let's see if that works. See if there's anything else. Okay, nice. Yeah, so there's a binary search version of this where you can basically just try to do some number of queries, make this line, and then go through the numbers and check if all the current numbers are bigger than the line. That's the other version, but this is like the better one. So this one is m plus n, because we're essentially going through all the queries and all the numbers once. And then space. So what did we make? We made a line, which is n, so, or m, I guess. Yeah. Okay. Yeah, so that's it. Definitely an interesting one. I think it's definitely closer to a hard. Yeah, so I'm guessing a lot of people didn't get this one. So yeah, let me know what you think, and let me know if this is helpful. Thanks.